Hello, this is Alan again on another of my videos on the ECL and HPCC subsystem. This team, I thought I'd do something on events, raising and fielding events between work units, and a bit on CRON as well. So yes, you come to HPCC and you think to yourself, oh yes, right, it's got events and it's got notifiers, so you can fire events, you can field events, and yeah, I know all that, blah blah blah, and I understand it all. So you go to the documentation and to read up the actual what's going on here, and you see, right, to raise an event, I've got an event and subtype, and subtype is, or it's a subtype, may contain wildcards to match. So in other words, enhanced matching, you think to yourself. And you get to notify, so that's the second parameter, and you get to notify and you think, right, its second parameter is any parameters you want to pass in XML, you pass as a second parameter. So you write your code like this. So this has got two parameters. An event has got an event name and its wildcard is just anything. And then my second parameter to notify is the information I want to pass between one work unit and the next. And then I have a nice fielding worker that's going to, let's say, read a data set from the calling or firing work unit when it's fired, and it's got this same event name here, and you think this is all going to work, and in fact it all compiles, syntax checks correctly and runs. Let's have a look at it. So let's submit that and see what happens. There you go, the worker's waiting now for its event, and in fact you can see it's an ECL watch. It's not a scheduled event, but if I search for Robel AF, I should find, yes, there you go, H4 worker is in a wait state there. All well and good, lovely jubbly. But if I actually try running this, and this will fire an event off, so what I want to do is fire that event off. So it fires, but it doesn't actually work. That's not picked up. So there you go. It's still in its merry wait state, and you think you're scratching your head because you can't understand what's wrong with that. Okay, I'll just kill that worker off. Well, no, I'll leave it up because it will fire correctly this time. So I'll leave that worker running because all it's doing is, the problem isn't in the worker, the problem's in the initiator. What you actually have to have, come on, is the event take its second parameter is the information you're passing, the XML of the information, and notifies only taking a single parameter. Now if I run that, this initiator this time, that runs, refresh, there you go, it's actually already changed and it's fired off. So what have we actually done? I've effectively created a data set in this initiator work unit, and I'm firing off information, notifying anyone who's listening on do it event, and I'm passing across this information. The information has to start with event, and then everything in that is your XML of information you kind of want to pass. And what I'm passing is my own work unit ID, because I want the worker to read the data set that's been written out in this work unit. If we go to the initiator function, this is just going to run this function when this event fires, and now it has actually fired because we haven't followed the reference manual. Event extra, this is just the XPath to the rooted on event to get the work unit information. And then there is obviously data set. One of the ways of creating a data set is to have dataset work unit and the named output, so you can read from one work unit to another. So I know the work unit ID, I know the named outputs because I wrote the code, the output identifier there, and I'm just outputting the work unit ID of the thing that's fired it, and this data set. So if we look at what this worker initiated, this worker created this data set, and if we go over to the output for this one, this work unit 756, so let's look at 756, yes, 756, so that's the work unit, and this is the data set that's been read from the other work unit. So that's worked, but as I said, it's a bit tricky getting to this from the reference manual. Now, what else to say about this? There is obviously a CRON is an event as well. That only takes a single parameter, and here this is the good old-fashioned Unix type construct for specifying schedules that even grandfathers know. By the way, I know a very handy cheat sheet for this, CRON tab GUI. I'll put a link to this in the comments below, but you can do things like start every minute, or you can just play around with your CRON tab here, and it just tells you in English what you're going to do, how it's going to schedule something. Put 8 there on the 8th day of the month, you see. So that's a very handy crib sheet for this construct here. And what I'm doing here is I'm just going to put a minute turnover. So I want to output the current time. Let's say I want to print the time when this event happens. It's going to happen every minute according to this CRON event. I just want it to happen 5 times as well. So I can start that going. This is fairly straightforward. So if we have a look at that minute turnover, it's undefined at the moment. When eventually it fires off, just hang around for a minute. Let's see. While it's doing that, an interesting construct is that current date time in the standard date library is documented, but time to string, if you search your documentation on the standard library, you won't find it. So there's an awful lot of goodies in these. If you go to your ECL library that you've got with your distribution, and in STD, there's also all the libraries there. So there's this date function, and just go through and read all the interesting little goodies that are in there that aren't actually documented. So here, time to string gives given it a time t format will generate a formatted string, and the format is that good old-fashioned %h, %m kind of format, but you won't find that documented. But it's been stable for years now, so I don't know why they haven't documented it. But anyway, that's why I wanted to show that. It's got a handy little hint. Let's try refreshing this. It should have been a minute up by now. Yes, it has. So if we had enough time to kill, we could wait for that. It's still waiting because I asked that to fire 5 times, so we would actually see that click over. But I think at that point, I think I've demonstrated enough on CRON there. So let's do abort work unit, abort there. Now that's straightforward using a CRON, but what isn't straightforward is how you actually use CRON in a function. So you start off thinking, well, I took some time to work this out, I must admit, because if I do something like this is my first guess, and so I wanted this function to cron up, so I put the cron, I tried to put the when clause on the function itself, and you get this error. So the next thing I tried doing was actually putting this on the function return, like that. And again, doesn't fail. What you actually have to do is do what I've displayed here, is effectively return something and put read s, the function definition constrained by when, actually as a separate action. Now you can cron up this. I've got this same work as I showed demoed 5 minutes ago. I'm just scheduling it up to 1:30 in the morning. So this is how you put a cron into a function. That's a handy thing. So let's just see that if that works now. And that should go into await state. Yeah. And if we go to ECL watch, yeah, if we go to scheduled, event scheduled, then we should see, yeah, there we go, 1:30. That work unit is scheduled to run at 1:30. So it's just a little something that took me, might save you 15 minutes of your life trying to work out that. Anyway, I think that's all I've got for this video. Hope that's a few interesting bits and pieces that will help you out, and I'll see you anon. Cheers, bye.